The graph of tangent. The quotient identity states that the tangent of theta is equal to sine of theta over cosine theta. So we can use this identity and a table of sine and cosine values to sketch a graph of the tangent function. So I'm going to use these specific angles in the table that I have already written in, and then figure out what the sine and cosine of those angles are. And again, I can remember what I have going for my unit circle to help me with that. And then determine a point on the graph. Now, point on the graph of what? This is going to be y equals tangent of theta, so this function there. And so my point will start with the angle that I have on this row and then be, this piece here. Okay, so then once I have those points, I'm going to graph them. Now I'm using a certain set of angles. Now the graph of tangents, the domain of tangents certainly contains more angles than what I have in this first column, but I'm kind of picking them carefully to kind of show you what it's going to look like at the end here. Okay, so let's look at negative pi over 2. Where does that live? So I'm just going to draw a unit circle for us. That lives down here. And so sine of theta there is -1. Cosine of theta there is 0. Well, what direction am I dividing? Sine over cosine. So if I have sine over cosine, -1 over 0 is going to be undefined. So, okay, our first point doesn't even make it out of the gate. I want to write undefined here. Okay, we'll try another one. Negative pi over 3, that one's here. What is this point right here? Well, this is 1/2 negative root 3 over 2. Okay, so if I am using that point there, so I'm going to have negative root 3 over 2 is going to be the sine value. 1/2 is going to be the cosine value. And now I just need to take sine theta divided by cosine theta. All right, when I do that, I get -3 here. All right, negative pi over 4. Well, I know at negative pi over 4 that sine theta is negative root 2 over 2, but cosine theta is root 2 over 2. And when I divide negative root 2 by root 2 over 2, I just left with a -1. Okay, great. Let's see. They were supposed to be putting the point on the graph. Let's go back and do that. Okay, on to the next. Negative pi over 6. That's this one here. This one is root 3 over 2, comma -1/2. Okay, so for that one, I have -1/2 for my sine, positive root 3 over 2 for my cosine. And again, I'm doing this divided by that. And what happens when I do that? Now I have negative pi over 6 for my input, but my output is just the reciprocal of what I had before. So it's -1 over root 3. Now, oftentimes we are going to say rationalize the denominator, and we can here, but since we're just trying to get points to kind of approximate what this graph will look like, we're just going to leave it like that. All right, at 0, sine of theta is 0, cosine theta is 1, and so 0, comma 0 divided by 1 is just 0. What about pi over 6? Okay, so now I'm looking in quadrant 1, and I'm right here. So my sine value is just up a little bit, and my cosine value is the one that's out more. And then 1/2 divided by root 3 over 2. All right, I'm going to get pi over 6, comma 1 over root 3. When I'm plugging in pi over 4, this is where they match, root 2 over 2, root 2 over 2. And so I'm going to get pi over 4, comma 1. When I'm at pi over 3, okay, that one I'm over just a little bit, but up more. So my sine is going to be the bigger value. And then root 3 over 2 divided by 1/2 gives me just root 3. So I'm going to have pi over 3, comma root 3. And then at pi over 2, I have 1 for my sine, but I'm back to 0 for my cosine. And so in this case, I have undefined. Okay, so what I have are some points for me to graph. Now, most of these look good, except I've seen that I have like this root 3 value and 1 over root 3. I'm going to want to approximate those. So I'm going to bring in my calculator down here. And let's see, what do I need? I need 1 over root 3. So let's do that one first. 1 divided by root 3. And I get about 0.57, or so let's just say about 0.6. And then for root 3, so new line, root 3, I get about 1.7. Okay, so about 1.7, and that's for this value specifically. And that'll just help us get a better idea of what's going on here. Okay, so now I'm ready to graph. And what I can see is that where I was focusing was between negative pi over 2 and pi over 2. So what I'm going to do is at negative pi over 2, I'm going to draw in this vertical asymptote. Whoop. Okay. And then I'm going to start putting in my pieces. So let's see, I want to start at 0. I don't have to start at the top, just so that's the part I can see right now. So if I plug in 0, I get out 0. So I have this point here. When I plug in pi over 6, I get about 0.6. Now notice that each tick mark here is pi over 6 on my graph, so that makes it easy. So plug in pi over 6, output is about 0.6, so a little over a half. Plug in pi over 4. All right, pi over 4 is halfway in between the first and second tick marks, and the output is 1. And then when I plug in pi over 3, the output's about 1.7. So pi over 3 is 2 pi over 6. So it's that second tick mark, and then the output is 1.7. Okay. And then at pi over 2, I'm undefined. And so then what I notice is at negative pi over 6, my output here is about negative 0.6. Okay. So for negative pi over 6, now I'm at negative 0.6. Okay. Negative pi over 4, negative 1. Remember, pi over 4, careful here, is at this piece here. So negative 1. And then negative pi over 3, negative root 3, we just said that was about negative 1.7, since positive root 3 was 1.7. And then at negative pi over 2, I'm undefined. So I get this kind of snaky looking thing. Go ahead and put that in like that. And that is what my tangent looks like. Now, my tangent period is pi because it's this ratio. And so even if I have a new sine value and a new cosine value, if they're just differ by a sign, then sometimes those negatives cancel out. And so I end up getting that same value. So it actually starts repeating the behavior sooner than in a cosine or sine function. So we have the period is pi. And so if I draw another one of these vertical asymptotes, this cycle is just going to repeat. So instead of crossing at 0, I'm crossing at pi, and then I'm kind of going up towards it and then down kind of away. And it's going to have that same shape. Obviously, the more points you draw, the more accurate it is. But that's pretty good. I'll draw in another one here, starting at negative pi for its intercept. So I just want you guys to get the basic shape of it and then kind of thinking about where those restrictions are. So what's our domain? Well, the domain looks like everything is looking good except for at multiples of pi over 2. So it's the same idea where we say all theta except for thetas that are not equal to pi over 2 plus n pi, where n is part of the set of integers, right? So every angle is okay as long as you are not either pi over 2 or some multiple of pi over 2, because anytime, like if we start at pi over 2 and then I add pi, I get somewhere bad. If I'm at pi over 2, I subtract pi or subtract 2 pi, right? I land somewhere that's not allowed. What about my range? Range is all real numbers. Range is all real numbers because it goes all the way, decreases without bound, going this way, right? And increases without bound going that way. I don't skip any values. Period is pi. And then what about even or odd? This one is odd because I can see that if I rotated this piece just in this first quadrant piece here, if I rotated it down, it would land here. And if I rotated this piece, it would land on top of there. Same time with this piece over here to the right. If I rotated it, it would land over here and this one would land on it. And everybody kind of pairs up like that. All right, so this is an odd function, and I can say that tangent of negative theta is equal to opposite of tan of theta.